Hello, welcome to one more English lesson. Yeah, as we always do, we're gonna work on science, okay? And of course, I hope you are enjoying learning. I mean, uh, the maximum possible, as we say, right? Let's go on for today's lesson. And the title of the topic of the day is reversible change. Okay, have you ever heard about that? Maybe no. So if you haven't, so let's go on. Let's go inside of the topic and just follow me. Okay, so let's go there. Okay, moving on. As you can see here on this side of the screen, and we have the title reversible chains, and we're gonna move on. Yeah, we're gonna continue the reading. So just follow me. Okay, so on reversible chains. So the first thing that we have to get here is the meaning of the word reversible. Okay, so that is the word, yeah, reversible. Teacher, what is reversible? What is that? It's something that it can be reverted, as we say. Is that maybe there is some change in one specific item, and if we want to make it get better, uh, in a way that it was before, like go back, turn back in time, like that. We can revert it. We made one change we didn't like, and we want to make this product in the same way as it was before the change. So if you have this possibility, yeah, if the item you were working or you were using um, is possible to do that, so it means that the item is reversible, or the material. Okay, so and then of course here we're gonna see some change that it's possible to make it go back as it was before. Okay, so I hope you are understanding. If you don't, again, you can send me questions, you can ask me, right? Or and also you can check for yourself, like Google the words. And but I mean, that is the point, right? So let's go on. I'm gonna begin the reading here. So just follow me. Let's go on. Okay, so there are two types of chains you need to know about: reversible and irreversible. Okay, so of course we can see that if something is reversible, you can make it in the same way as it was before. Yeah, you can make it go back, turn back. Yeah. um and if it is irreversible, so I mean, it is obvious that you cannot do that, right? So, and continuing, there is plenty of information about both coming up on the next 4 pages. Which means that in the next pages we're going to check a lot of information about reversible and irreversible. Okay, so let me go down a little bit here. We have this subheading here, okay? And the name is Some Chains Are Reversible. So let's read a little bit about that. Just follow me. In a reversible change, a material turns into something that looks and feels different, but it isn't changed forever. And the material can be changed back, so it looks and feels the same as it did before. So basically, it was, I mean, what is said here, it is the same as I said to you before, right? We have reversible, we have forever, we have change it back. Okay, so I hope you know these words. If you don't, you can ask me, but anyway, I'm gonna give the translation to you. Okay, so reversible, I have already told you, so I will not say the Portuguese version for that. Uh, Forever means eternamente, okay? So, but it isn't changed forever. A mudança não vai durar, né, para sempre, eternamente. The material can be changed back, ou seja, você pode fazer com que o material ele retorne a ser o que era antes, ele pode ser mudado, né, para ficar da mesma forma que ele era anteriormente, okay? So this is the thing. So it looks and feels the same as it did before. So very good. Continuing, okay? Now we go here to the second part. These are reversible change. So we're gonna see an example here, okay? And we have two pictures, as you can see, and this is about number one, and this pen here, yeah, like this soup is connected to number 2. So let's read. Water turns into snow or ice when it gets very cold. So there is this transformation, right? When the water gets really, really cold, it transforms itself, right? Okay. And when it warms up, when the temperature goes back, right? It was very cold, but now it's getting hot again. It's getting back, I mean, to the same temperature as it uh, had before. Yeah, okay, as it was before, as we can say. So when it warms up, it turns back into water. So I mean, because the temperature got back uh, to the same temperature as it was before. So of course, what had become snow now turns into water again. Okay, so we have this transformation, right? And we have example number 2. Chocolate goes soft and gooey if you heat it. When it cools down, it goes hard again. Here we have these two words, soft and gooey. Soft and gooey. So let's analyze, what is it? Okay, so I changed it here a little bit my camera, and as you can see, we have the definition for this word, right? Which is, what is it?
Gooey.
Gooey. Gooey. Okay, and of course the definition is sticky and soft. Again, sticky and soft. Soft, teacher, I know what is the meaning of soft. Maybe you don't know the meaning of sticky, okay? Something that is sticky is something that, for example, yeah, imagine, I don't know, let me get a product here. For example, imagine I have this paper and supposing, right? Let's suppose that this is sticky. So when I put it here, it sticks. Ah, yeah, gruda, okay? So that is the definition of stickies. Some material that is sticky é um material grudento, okay? So getting back, let me go back here to the page. So of course, if we say that the chocolate goes soft and gooey, okay, it means that it became very soft and sticky, yeah, grudento, okay? If you heat it, of course, if you make the temperature goes really high, yeah, make it hot. Heat is similar to hot, okay? And of course, when it cools down, yeah, when the temperature goes down again, it gets colder, yeah. So the chocolate, yeah, like you can feel the texture, right? Like the if you touch it, you're gonna see that it's gonna get hard again, yeah. For example, if we go to the supermarket, yeah, and we when we buy, oh sorry, a chocolate bar, right? We see that this is hard, right? Because the temperature is like it's kind of a cool, right? Of course, it gets if it gets really hot, you're gonna see that it's gonna melt, yeah. It's gonna become like a liquid. In that case, soft and gooey. All right. So I guess not a big deal up to here. Let's continue. After that, yeah, as I have already explained you, we have this information here in blue. The materials change back to how they were before, for sure, right? This is a very obvious explanation. Yeah, like when the temperature goes back, the material it the transformation that happens, yeah, make it um change back, you know, like go back to the way, yeah, to how they were before. So that's the thing, okay? Very good. So if it's everything okay, if it's everything all right up to here, let's move on. Okay, again, if you have questions, just ask me. Going down here, we have this, yeah, this next part, right? Which, by the way, is the last one. I'm gonna change my hand here a little bit up. Okay, so that you guys can see everything. So, oh, sorry. All changes of state are reversible. Again, all changes of state are reversible. Yeah, that's a very good one, right? So all changes of state. So ever it doesn't matter what is the state of the material, right? If it gets liquid, if it gets like gas, right, or hard. So I mean, because you can change the temperature, it means that you can change the state of the material. So and this is what we're gonna read now. So the first one here, yeah, we have this one, heating. So let's see that. Okay, so let's read. And heating a solid can make it change into a liquid, which means it melts. That is the changing. Okay, so yeah, I guess you know melt and you know liquid, right? And you know solid. If you don't know, please check the meaning of the words for me, okay? About melt, liquid, and solid. All the words that have a different color, so please, you always have to check, okay? What I mean when I say check, you have to get the Portuguese meaning of the word or the Japanese meaning of the word around, like the one uh, that you feel better to understand. So, and there is this picture here, right? We have an I mean some ice cubes and the sun, yeah, is there outside of the window, and probably it's melting like the ice cubes inside here. Okay, so let's get that. Okay, and of course, right, this recipient, yeah, where we have the ice cubes, the name is ice mold. Okay, ice mold. I'm gonna write it here for you, just for a matter of curiosity. Okay, ice mold. All right, so let's go on. Okay, so as you can see here over my head, right, ice mold. Okay, so what happened? So let's read what happens here, right? If you leave ice cubes in a warm place, say on a sunny window sill, for example, they will melt and turn into water for sure, right? If you leave the ice cubes there, even if they are frozen, yeah, because of the heat and because of the temperature, it's gonna change because it's hot, and you're gonna see that the state will change. I mean, yeah, what was solid will become um, water, yeah, liquid. Okay, so that's very obvious, right? So this is the first one. Second one, cooling. Cooling the liquid turns it back into a solid, like a freeze. So here there is a picture of a freeze, right? And then we have this ice mold and they're putting it back into the freezer. And of course there is water inside of the ice mold. So let's read. And if you put the melted ice cubes back in the freezer, they will turn into solid ice again. So it gets back to the state it was before, right? Again, we have the word freeze, right? Okay, backs into a solid. Okay, freeze. So if you don't know, check the meaning of the word freeze. Okay, if you don't know melt too. So these are the words that I want you to check. Okay, easy. Go to the dictionary, go to the Google Translate. Just very easy to get the meaning, right? No problem. I guess so. Let's continue. And going down here, yeah, you can freeze and melt over and over again. You can repeat the process as much as you want, okay? But you won't end up with anything other than the liquid that you started with, because freezing and melting are reversible. Okay, so I mean, as they are reversible, I mean you can make it solid and then get back to liquid, and that's it. If you continue repeating the process, it's going to be changing these two different states forever, like, and that's it. Yeah, and there is no secret. Okay, so again, over and over again, this word here means repeating and repeating. Okay, and reversible, it means you can change the state to the way that it was before. Okay, the state. So, and then we have this last part here on evaporation and condensation are also reversible change. I mean, even if we make this, yeah, different change here, they are reversible. Yeah, depending on the temperature, it gets back to the way that it was before. An example here, we have this picture. Yeah, like it's like the ocean. There is a shark. There is a man swimming, and we have here the, yeah, like this vapor going up and turning into, yeah, like this cloud. And anyway, so let's read. So heat from the sun, yeah, the sun is there, as we can see, is he is even wearing sunglasses, yeah. So the heat, yeah, o calor, from the sun makes the water evaporate, yeah. So it's very hot, so the liquid, the water in this liquid state, it will evaporate, go up. And when it gets there up, it's cold up, right? Because the air, as high you go, colder it's gonna be, right? So it's uh, it's cold up in the air, so the water vapor condenses into droplets. Okay, so it will condense and then get back again in this liquid state. Yeah, because it will become droplets. Yeah, gotinhas, right? No problem, I guess so, right? So check it out here. I hope you are getting that. Yeah, this section 7. Okay, so this is the process. Yeah, like the reversible ones. I mean, you can make a liquid become like an hard, yeah, way, like water into ice, for example, and then changing the temperature again, you can make the ice get back, yeah, get back to the liquid form. So I mean, and you can do that forever if you want. All right, so let's go to the next page right now. Okay, so continuing here, yeah, in this topic, reversible chains, yeah, we have a different example here. Mixing is a reversible change. So when you mix, yeah, two different materials, or I mean products here, we can see that I mean normally, yeah, it is reversible. So let's read that. Number one, mixtures can be separated by sieving, as we have read before, filtration, and evaporation. So these are three ways that we can do this separating action, right? Number two, mixing is reversible because you can get back exactly what you started with. For example, and then let's see how is it why we say that this is reversible. We have some examples here, right? We have these pictures, and if you analyze it, let me see. Let me get here. This is rice, yeah, a rice bag, and we have some tomatoes mixed with rice. Okay, so this is an example, of course, right? But let's see. So let's begin with the rice. We have the rice and we have the tomatoes, yeah, or the tomatoes. And as we can see in the first picture here, they are gonna mix, yeah. And in the second one, mixture of tomatoes and rice. So they are mixed. And yeah, and if you go to the next one, if you do this action like of sieving it, yeah, you're gonna see that it's possible to separate, yeah, especially because they have different sizes. So by sieving that, yeah, doing this filtration, yeah, and you're gonna see that the item that we used here, yeah, kept the tomatoes, right? Because they are bigger, and the net, yeah, the little holes to pass, the size is different. Yeah, is smaller than the tomatoes. And then down below, yeah, because rice was really smaller. I mean, if you compare that with tomatoes, so of course it passed through, this net. Okay, so that's the point here. Okay, so this is an example how we can do that, right? And let's continue. We have more here. And take a look on that word. That's a new word. Okay, so like take a look on here. This one we call dissolving. Dissolving. Okay, again, on what is that? If I dissolve something, so I'm gonna read an example to you. Okay, so if a solid substance dissolves in a liquid, it is mixed into the liquid so that it becomes included in it. Yeah, so when you dissolve is when you put, like as I told you before, this solid substance and you mix that with a liquid, and then they're going to become one. Yeah, so that's why we have here dissolving is a reversible change. I mean, even when we do that, even when we mix, then I mean it's possible to reverse it. Yeah, I mean to make it get back. So let's see. We have the example here using salt. Can you see? Okay, and let's read. So salt gets mixed up with water in a jar. Okay, in a jar. So this is a jar, and then they put salt inside, and then they mixed. And number two here, after stirring for a bit, you can't see the salt anymore. Yeah. So stirring, when we say stirring, I think what we can do, yeah, what if we stir and then we cannot see the salt anymore, yeah, like it because it seems like they became one. Stirring is the action of you like doing this movement. Yeah, you get like a spoon maybe, and then you get like go like mix the liquid. Yeah, okay, with the product. No problem. Are you getting? So let's continue. Okay, and then on. So these are the two process, and then we have a little information here. Okay, if you don't believe the salt still there, taste the water. Okay, so even though the salt will disappear, it is still there. If you don't believe it, if you drink the water, you're gonna see that the taste of the water, it's gonna be a little bit different. Yeah, it's gonna be salty. That's why this little man here said, "Yeah, what is that?" Right? So going down, let's go here to the last part, right? And then let's read this blue one. You can reverse the change and get the salt back. So you see, even though by doing the mixing, one of the products which was salt disappeared, is it? I mean, it is possible to make it, yeah, to get it back. So let's see. Number one, heating the water gently will make it evaporate. So if you make the temperature goes high, right? And leaving the jar on a warm radiator, okay, for a while should do the job nicely, okay. So radiator, what is that, teacher? Radiator, this is a part of a car. I don't know if you guys have already seen that, but radiator, it's a part, yeah, of it's a car part actually. It's something that we use inside of a car. Yeah, it is necessary to keep the heat of the car. Okay, so this is radiator. Again, if you don't know, feel free to check it out. Yeah, like to Google that and to see what exactly is that. But we use that in a car. Okay. Actually, I'm gonna show you a picture of that. Give me a second. Okay. And as you can see here, right, we have many examples of an, I mean, a radiator, right? Especially, I mean, for example, this one here. I don't know if you can see. You're gonna make it get closer, like this one here. You see that? That this one, yeah. This is, they are putting that in the car, right? So this is the most common way, yeah, that we see, yeah, radiator, and we use that for car. Of course, there are different. I mean, there isn't only these kind of a radiator, right? And not really in Japan and in Brazil, we don't have it very much. But for example, if you go to the UK, right, inside of some houses, okay, there is actually a radiator, okay, and I'm gonna show you, okay. I'm gonna give an example here to you. Check it out. That I'm gonna share a picture with you, and there is this man here. Can you see that? Take a look on this man, like in red. This is a radiator as well, okay, but it's inside of his house, and yeah, and probably he uses it to heat the water, right? So maybe, I don't know, maybe for sure, yeah, maybe they use it to, I don't know, maybe to pass gas inside, right? But so this is a radiator, okay. So in Brazil we are more use it to see the car one, but there is also a similar one that we use inside of our house, of our, okay, of our apartment. But that's it. That is the point. Yeah, are you getting that? So if it's okay, let's move on. Let's go to the next part. Okay, and then again, I'm gonna read number one for you. Heating the water gently will make it evaporate. Leaving the jar on a warm radiator for a while should do the job nicely. Of course, yeah. If you do that, if you leave it on a radiator, because it, yeah, it gets really hot, yeah, as we use it. So you're gonna see that they're gonna do the same job. I mean, in the same way, the water will evaporate, right? So, and number two that we have down below here, just by my side, and when all the waters dry it out, there are salty crystals left at the bottom of the jar. The change has been reversed. So as we see the water, yeah, as we see in this picture here, the water has evaporated, okay, and down here we have the salty crystals, yeah, like, so I mean, what happened here? as the water has evaporated, so there was also the separation of the two products that we have inside, which was water and salt. Okay, so now we have only these crystals, right? Salt crystals, actually. Okay, so this is how it works. Yeah, so it's possible to reverse things. Okay, we can make the change, right? So for today's lesson, basically that is it. Okay, so don't forget, right? I'm gonna show you again, yeah, like the dissolving, the ways that we can work it out, and mixing, and the things are reversible, right? Okay, so this is very important. So we have studied here, we have gotten 2 pages here explaining, giving examples on how reversible materials, yeah, reversible things, yeah, and I mean how it works, and if we can do or not. Yeah, we can help at this process, and of course we could see that we can help that. Yeah, like for example by heating the water. Yeah, if the water is mixed with salt, so we have the separation. So I mean there are there are plant, yeah, there are many 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 things that we should study. Okay, and of course we should learn as well. So please, um pay attention, yeah, on the words, make notes, write it down on your notebook. Okay, because if we don't write it down, we forget it. So please be careful with that. Okay, and of course I hope you have enjoyed the lesson. So thanks for always. And again, if you need to go back a little bit the class, yeah, watch again the video, and then um I'm gonna give you now the homework. Yeah, I'm gonna explain you what you have to do. Okay, so give me just a second and take a look on this one. Let's go on. In this last page here, right? Okay, and we have these 2 explanations, right? How things are reversible. Yeah, we had this explanation, and also if we go back here, right, in the first page, also there was the explanation of how the chains are reversible. Okay, so what I'm gonna ask you to do, it's simple. I want you to read the 2 pages. Okay, this is gonna be homework. Read the 2 pages and sum it up. Okay, make a short version. Yeah, you're using your own words. Okay, explaining. Okay, so okay, there are some reversible chains, and what are they? So explain that to me. You can use the examples that we have read here, that we have in these 2 pages, but write your own explanation, okay, about how it works, what is reversible, and how it works. Então, escreva a sua própria explicação de o que é isso, reversible, yeah, e como que funciona. Ele deu exemplos, né, na segunda página. Então, leia aqueles exemplos e tente escrever um, só que usando as suas próprias palavras em inglês. Lógico, você pode repetir as palavras né, que a gente viu aqui nas páginas, mas mostre, né, escreva por conta. Né? Olha, professor, a gente leu 2 páginas e aprendeu sobre, né, algumas mudanças que são reversíveis, e eu vou escrever um pouquinho sobre o que eu aprendi. Então, eu aprendi que algumas mudanças são, né, reversíveis por causa disso, disso, disso. Exemplo, da 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 da, like that, okay? So this is what I want you to do for me for homework. So, of course, if you have questions, just send me a message, okay? So, thanks a lot. Don't forget to keep in touch, keep communicating with me, and I see you next time. Bye bye, guys. Take care.